Hi everybody, welcome back to the channel. Sorry it's been a while, I've been a bit remiss. So this is an Archimedes A3010 and it came off eBay thanks to SparksUK for pointing it out on eBay. It came from a guy that normally deals with Commodore gear and he listed it as not really knowing what it was. It's an Acorn Archimedes 3010. You can see the Acorn logo there. First things first, to get rid of this battery, and this floppy cable doesn't look fantastic. It doesn't want to come out there. The cable tops come away from the bottom. Same there. So I'm just going to take that out for now. We'll deal with that later. See what I mean? The actual things come apart there. So we've got continuity there. 93 ohms, yeah. Got continuity there. So this is obviously one supply, this is another supply. This is separate from this. I think that's it. So it doesn't look like it's blown in terms of the wire being broken. But that's not to say it's going to work. Now I'm going to have to keep picking it up from this heavy lump here because otherwise it's going to damage the board. So what we're going to do first of all is just clean it up. There. Okay, so the usual, just a little white vinegar. Anti-static brush, if I can find there it is. Already I'm itching from this stuff, it's horrible, this battery acid. I'm just gonna get the old fizz on. You can see them around here, these have gone green, these pins. Just show you. See the pins in the back here have gone green. It doesn't look that bad. Now these are going to be the ROMs. This is RISC OS, probably 3 is it? I'm not sure. Let's just pull those. Right. Pretty good. Doesn't look bad at all. I'll give them a quick wipe down. Dual wipe sockets. So that's good. I just want to get rid of any oxidization on the pins. I'll stop it making contact. So the little nib is there at the top. 5 glass pens in as we've got it out. I've got this strip wrap on. I've got that on, so don't panic. Okay, so let's do a couple of really basic tests. Is the fuse any good? Because that could tell us something. If the fuse is no good, the fuse is fine. Okay, does the switch work? Yep. Got this moody looking. I don't know if you can see that. It's like there's been an overheating inside the transformer. Maybe. It doesn't look coherent enough to be a company market. It might just be a manufacturing defect. It looks a bit sus. I'm going to check that. The board is now clean, and I just want to do a couple of sanity checks. So I've got the multimeter. You've got 0 volts, 5 volts. They're not shorted. You've got 0 volts, 12 volts. They're not shorted. 0 volts minus 12 volts. That's not shorted. So we know the switch works, we know the fuse didn't blow, we know we've got no shorts on the 5 volts or 12 volts or minus 12 volt rails. Now I'll just quickly pop you on the scope and show you what the damage is like on the board. Pitting in these traces to the floppy drive, they're all going to be shot, they'll probably need repairing. Some of those lines are going to be broken. Shot. Okay, so these are the traces I repaired. I ended up going over them with solder. I don't want to take up too much of your time with that. There's a few bits of magnet wire patched on there as well. Obviously I've taken that connector off. That was the battery. These are all pretty furry, they're still a bit green. Down to about there. So not terrible. I've got power coming in here, 0 volts and 5 volts from my bench power supply. Very importantly, I have disconnected that diode, which I told you about. We can put that back later, but I wasn't sure when I got this because it just came as a board. I didn't know how bad the power supply was, and it's got this kind of melted bit at the top. I think that's just the potting of the epoxy. Anyway, so this is pin 4 of the arm. 72 megahertz, I mean that's over the top, 72 megahertz, see? That's fine. So on pin 4 of the arm 250. You have pin 11, 25 megahertz. So we've got that. There's a 2 megahertz clock on pin 4 of SK5, which is the internal expansion. 1, 2, 3, 4. It's got to change the scale a bit. 2 megahertz. And apologies for the dodgy camera angle, I'm trying not to touch anything on this board. A reset goes high and then low. And now we're going to scope the address line. So what should happen here is that each line should be half the frequency of the previous line. So LA2 is pin 10 on here. 1, 2, 3. They go from 1 all the way around clockwise normally, apart from the arm, which I think is anti-clockwise. Well, it is on the A3000. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. You can see there we have. We could 6 megahertz signal, yeah. 9. So that was LA2. So 9 is LA3, we have a 3 megahertz signal. Pin 8 is LA4, and that is a hot mess. And it turns out that's because it's not connected. But this test shows you that there is a problem with the address line 4. That should be 1.5 kilohertz. It's all over the show. Next one, got to adjust the throughout clamp there. 750 kilohertz, which is half of 1.5. And we go on, and it turns out 375. We keep going. They're all halving down. 187. You have to keep adjusting it for it to show up. 92. 46. You get the picture. What's shown us here is pin 8, which is LA4, was a load of mess. All the others, you can see I've written down the frequencies. 50. It's not perfect, but it's halving down each time. It probably is perfect. It's probably because I wasn't doing the scale exactly right, but it's halving down each time. Apart from pin 8, LA4, messy. There, right, so we're there. So from here, it should go to pin 8. Well, it would have done by now, wouldn't it? Right, it also goes to pin 5 on this expansion thing. 1, 2, 3, 4, 5, which it does. Right, so I just put a little mark with a permanent marker there, which you can wipe off with isopropyl, and traced it through. So it goes from there, and it goes under the board, and it turns up on pin 5 here. And then from pin 5 here, it goes up to here. Right, so it's getting that far under the board. And then from there, it goes onto this chip here. And it's also supposed to go to 1, 2, 3, 4. Oh, fuck. Well, it doesn't, does it? So what we're going to do, we're going to put a patch wire in for now, because I'm not pulling the socket off. It's just, I can't be arsed. Put a patch wire in between that via and that. These two, pin 8 on these two is linked. So 1, 2, 3, 4, 5, 6, 7, 8. There you go. That pin looks a bit moody, but I think it's all right. It's pushed in a bit. Okay, so there's our handiwork. Just do, I think it was 5, pin 5 on this, wasn't it? So it's either going to be 1, 2, 3, 4, 5. Or it's going to be 1, 2, 3, 4, 5. Yay! I'm actually going to plug in the post box and see what it shows me now. And we got nothing. Okay, so that single patch wire didn't solve everything. I've made a spreadsheet of all of the data and address lines, pinouts between the ARM and the ROMs there, and we're also missing a data line, which is supposed to go from pin 24 here. That's 22, 23, 24. I know them by heart now. It's supposed to go to pin 73 on the ARM. Nothing. I've traced it through to that patch there. That's pin 73 on the ARM. That one there. Beep. So from there, it went over to here. Okay, gets that far. It's supposed to, you can see it, it goes down under the ROM, and it's supposed to go to 22, 23, 24, but it doesn't. So I'm missing a data line. So I won't bore you with that. I'll patch that in and we'll try the post box again. Okay, so there's our patch wires. They're not very pretty, but I'll sort them out properly if they actually work. Let's see if they do work. This is the post box. You've seen this in a previous video. I didn't make it, this guy did. If you want to look more about it, that's where you go. I've 3D printed this crappy case for it. Basically ground and 5 volts, and then you've got various pins that line up with the diagnostic port on the A3010 board. On the A3000 didn't have a diagnostic port, so you saw that's a bit of a sort of a bodge job. Same signals, but you have to pick them up from somewhere else. The idea of this is it decodes the boot process or the power on process, and it should pick up how far it's getting during that process, throw any errors onto the screen via a USB to your laptop. What I'm going to do is power this up. I've got the correct polarity. It will tell you if you haven't. I'll just scoot you over to the computer. Okay, so it's pretty low tech. Just a quick proof that it all seems to work. We've got 1 megabyte of RAM, so that all seems fine. Mouse obviously seems fine. Mess around with paint, that seems fine. The reason that's jiggling around is because I'm using this at arm's length on a crappy desk, but the mouse is fine. Right, so things to do in the next video installment. Not much of a computer, I can't leave it like this. I've got to get a top case, got to get the keyboard working, make sure that works. I took apart quite a few components off of the disk drive there, so that will need sorting out, and also rechecking these traces. I think they're okay, but I remade a lot of these traces because they were rotten. The battery was there. So keyboard, disk drive, case, and I think then it will be a proper computer. I just want to say thanks to a couple of people. Thanks very much to SparksUK for pointing out the board to me. Thanks very much to Gadget UK who gave me this base. So I've got something to put it in. Things to do that I didn't mention. I have, off camera, checked this power supply is outputting a stable 5 volts. And I have hooked up the dummy load to it with the rest of the board disconnected to satisfy myself that it's okay. I still don't know what this burn mark is in here. If anyone does, I'll be most grateful if they could give me a view. Obviously that is very heavy going. I took the connector off so I could jack in a 3-core bit of flex. That needs sorting out. That needs sorting out. And the other thing that needs to be done, I need to know why I can't get a VGA signal out of it, only RF. And obviously got to get keyboard and everything going. Other things I failed to mention in this video, with this button here, which is taped on, soldered on to where the Del key would be pressed, and that resets the CMOS and allows it to boot. I've done that in the other videos. But I'll link in the description the schematics I used, what else did I do? Oh, the pin out between here and here. Probably overcomplicated it a lot with a oscilloscope and everything. To be honest, you could have fixed this with a cheap multimeter, because all that was wrong was it was missing one data line and one address line. Apart from the stuff up here in the corner and on the back, which is battery damage, but I don't think that would have stopped it from booting. I think that was more to do with the floppy drive and the serial port. So anyway, thanks very much for watching. Let's just square you up there. Thanks very much for watching. Take care of yourselves, look after yourselves, and I'll see you all soon. Cheers, bye.